Hello, 8th grade. This is your Unit 4 review. So the first page you should have worked on was this self-reflection, just basically trying to figure out how comfortable you feel with everything, things you learned, what were hard, and what you can improve on. So the next page that you would have been looking at is this vocabulary review. So this top box again is words that you should try to figure out if you're familiar with, and if you're not familiar with them, then look them up, use the glossary, and try and figure out what each of those mean. So again, what I've gone ahead and done is I've defined each of them for you. So this first one is a function, a rule in which each input results in exactly one output. And if you remember that function machine, so we had some sort of machine. And the input goes in, there's a rule that happens in here, and then we have a value that comes out. Initial value in a linear function, the value of the output when the input is 0. So that if we have our coordinate plane, it's going to be on this y-axis somewhere. Input of a function is the independent variable of a function. That's the value that goes in. This is your input. Linear function, it literally says a line, if I cut off that AR. A function that can be represented by a linear equation. Okay, a line with, in my sentence has an equal sign in it. The graph of a linear function is a non-vertical, so it's not up and down. Straight line. A nonlinear function is a function with a graph that is not a straight line. So we might have a parabola, we might have a v that is our absolute value. Maybe you have x cubed, that's kind of an S shape like that. Various different equations. Output of a function, the dependent variable of a function. So again, that's what comes out, the output. Qualitative description, a description that focuses on the general relationship between quantities, often without using specific values. That's what we've been discussing most recently. So we're talking, is it ascending? Is it positive? Is it negative? Is it descending? Is it constant? So then ascend, you're going smallest to largest, or you're going up. Constant, a fixed, unchanging value or number within a given context, such as an equation or a function. So ascending is going up, constant is kind of straight, and then descending, largest to smallest, so you're going in a downward motion. Respectively, items in 2 or more lists corresponding to the exact order that they are listed, enabling a one-to-one pairing. And then varying, describing how one variable changes in relation to another. All right, so let's put this off to the side. All right, so let's go back to this page then. So we're going to use all of these terms to answer these questions. So question 1, antonyms are words that mean the opposite of a given word. What pairs of academic terms in the list are antonyms, and what do the terms mean? So looking through here, and again, if we're looking at this, some that we can discuss, input and output, those are opposites, but they kind of go together as well. Ascend and descend, and then constant and varying. So ascend and descend, with ascending meaning to rise or go up, and then descend meaning to fall or go down. And then constant and varying. Constant means staying the same. And varying means changing or different. All right. Question 2. Sketch and label a graph of a linear function and a graph of a nonlinear function. Then use at least 4 unit math or academic vocabulary words to explain the similarities and differences between the linear functions and the nonlinear functions. Just gonna grab another pen. Okay. So our linear function is always going to be up and down in a straight line, or not necessarily up and down. So you can have something that goes in this direction anyway. You can have something going in this direction. So I'm just going to do a basic line. Okay, so this one is linear. And then I'm going to do a parabola. And that one is nonlinear. And then to explain them, both of the functions, the linear and nonlinear, they have exactly one output for each input. However, the linear function has a constant rate of change, and nonlinear function has a varying rate. And then the words that we used from up top were output, input, constant, and varying. You could also say something like, this example, they both ascend in a positive direction. These both have an initial value of 0. You could talk something like that. Not all the graphs are going to look like that. You could include qualitative descriptions, anything that like that. All right, number 3. Rephrase the sentence in your own words. Daria, her mother, and her brother ran 5, 4, and 3 miles respectively. So if you remember from respectively, it was that corresponding piece. So Daria would go along with the 5, her mother would go along with the 4, and her brother would go along with the 3. So one way to write that would be Daria ran 5 miles. Her mother ran 4 miles. And her brother ran 3 miles. Okay, so you're just connecting those pieces together. All right, next page. Question 1. Brianna says that the graph represents a function. Is Brianna correct? Explain your reasoning. So if you remember, we do that pencil test. So we start at the left and go towards the right, And any place that our pencil touches more than one point, that is not a function. So here I have these 2 points on the same line. So no, it is not a function. She's not correct. So essentially what that means is there's 2 outputs for 1 input at -2. Okay. All right. Number 2. 2 friends are biking. Greta starts at mile marker 5 on a bike trail and bikes at a speed of 12 miles per hour. The table shows the mile marker Shayla reaches after biking different number of hours. What is the difference in the initial values of the functions? Record your answer on the grid, then fill in the bubbles. Okay, so we have Greta at mile marker 5. So we would have an equation like y is equal to 12x plus 5. And then we have, so this is Greta. And then Shayla. So here she starts at 8. So we have y is equal to something. We're going to add 8 because that's where she starts. And then we just have to figure out the difference between where she's at. So you can take any of these and find that slope. So we do the y2 minus y1 over x2 minus x1. So I'm going to choose 2 and 1. So I'm going to do 36 minus 22 over 2 minus 1. 36 minus 22 would be 14 over 1. So it's 14x plus 8. So those would be your graphs. And I was not paying attention to the question. You don't actually need that. So the initial value is this one. Our initial value is this one. The difference between those, 8 minus 5 is 3. So you do not have to do this. I know there was questions today while you were working on the review. If you want to fill in the bubble sheet, you can, otherwise skip it. All you do is you put the value in it and then fill in the corresponding bubble. You're all done. All right, number 3, Javier goes to the county fair. He pays to enter the fair and also pays for each ticket he needs for games, rides, and food. The equation y is equal to a 1.75x plus 5 represents how much Javier spends y when he buys x tickets. Which statement from the function are true? Okay, so when it says statements, we're going to pick more than one. Select all correct answers. Okay, so let's just go through each one by one and see if they make sense. The total amount Javier spends is a function of the number of tickets Javier purchased. Okay, so that's correct. So depending on how many tickets, that's going to be his total. So the more tickets he buys, the higher his total. The initial value represents the cost of one ticket. No, that is not correct. The cost of one ticket is our slope, the $1.75. That one is not correct. The rate of change is 5. That is also not correct. Our rate of change is $1.75 because that's what's changing. D, the variable x represents the number of tickets Javier purchases for games, rides, and food. That is correct because this is what's changing. So it's going to be dependent on that. And then it already says for the games, ride, and food. Okay, so the $5 is how much he pays to get in. The $1.75 is the games, ride, and food. All right, so the initial value is 5. That's correct. He's going to pay that $5 to get in no matter what. If he doesn't play any games, he doesn't go on any rides, or he doesn't buy any food. So A, D, and E are correct. All right, number 4. Karina buys a painting. The price of the painting slowly decreases at a constant rate for 3 years. The price increases faster during the next 2 years. And then it stays the same for 2 years. Then the price increases slowly at a constant rate for 3 years. Sketch the price of the painting as a function of time in the coordinate plane. You do not have to do this, but what I would do is I would mark off the different intervals and then put the graph in there. So I have 3 years at first, then I have 2 years after that, another 2 years, and then 10 years. So here we're decreasing at a constant rate. We're increasing. It's staying the same here, and then it's going to increase here. So let's just pick some sort of value, and it's going to decrease to here. Then it's going to increase. Let's see. It does not say it's a constant rate, so this one would be curved. Then it's going to be straight, and then it's going to increase slowly. Okay, so something like that. As long as you have these relatively close, that's all that you need. All right, last page. The graph shows a function. The equation that represents the function is y is equal to x squared plus 1. Tell whether the function is linear or nonlinear. Explain your reasoning. Okay, so just by looking at this, we see this curvature, and we also have this x squared. So this is a nonlinear graph because there is a curve. It is not a straight line. And the equation is not in the form y equals mx plus b. All right, number 6. Miles and kilometers are 2 different scales for measuring distances. A 5-kilometer race is approximately 3.1 miles, and a 10-kilometer race is approximately 6.2 miles. Write an equation that shows the approximate distance in kilometers, y, as a function of the distance in miles, x. Okay, so y is equal to kilometers, and x is equal to miles. So we have to have something where miles is equal to kilometers. So here we can find the slope. So I'm going to do 10 minus 5 divided by 6.2 minus 3.1, which is equal to 5 over 3.1, which is about equal to 1.6. Then what you need to do is you need to take, so we're going to put this into y equals mx plus b. You're going to take one of these 2 pieces and then add in the slope. So let's use the 10. 10 is equal to my slope of 1.6 times the corresponding miles, 6.2 plus B. So this simplifies to 10 is equal to 9.92 plus B. And if I subtract 9.92 from both sides, I have 0.08 is equal to B. So that is my initial value. So my equation is y is equal to 1.6x plus 0.08. All right, last question, number 7. The manager of a juice bar checks the price of a certain fruit. Company A charges $10.50 per pound. The graph shows the price that company B charges. So here we have 2 and 16. So I'm going to find the slope of that, and then 4, 32, 6, and 48. I'm just going to use my initial value because that's easier. So I have 8 minus 0 over 2 minus 0, which simplifies to 8 over 2, which simplifies to 4. Nope, sorry. Getting ahead of myself. 16 minus 0 over 2 minus 0 is equal to 8. Okay, so company B charges $8 per pound. Company B charges $8 per pound. Company A charges $10.50. Okay, decide if each statement about the two functions is true or false, then select true or false for each statement. It costs $80 to buy 10 pounds of fruit from company B. 8 times 10 is 80. That is correct. The initial value of each function is different. No, that's not true, because if I'm not buying any fruit, I'm not paying anything. Unless there's some sort of service fee like Amazon, that is not true. Company B charges $2.50 more per pound than company A. No, that is not true. Company B is actually $2.50 less, so that is not correct. And D, it costs $84 to buy 8 pounds from company A. So if we just do quick math, 1050 times 8, 0, 40, $84, that is correct. All right, so that is it. If you have any questions, please let me know. Remember to bring these back with you tomorrow and you can use them. Have a great night.